Hello everyone. Today I will discuss an Android application created using Android Studio. This application's name is MVVM01 and we have used view model in this app. So now the question is, why do we use view model? The view model is an architecture pattern used in Android app development to improve code modularity, maintainability, and testability. By using MVVM, we can separate UI logic from data logic and ensuring that data is not lost when the UI changes. That's why we have used MVVM in this app. Now let's talk about the first activity is main activity. Main activity is a part of an MVVM based Android application that loads codes and displays them in a recycler view. Here, main activity is the main screen of the app and that extends app compact activity. Now here I have declared the binding variables and the codes view model variables. The binding this an instance of activity main binding which is associated the XML layout, and the late init is used because it will be initialized later. As like the codes view model, this is an instance of codes view model. The by view model delegated is used to get a view model instance from view model provider. Now the codes adapter is an instance of codes adapter which acts as the adapter for the recycler view. So now what is XML layout? The XML layout is an Android is used to define the user interface of an application. It specifies how UI elements are arranged on the screen. The user can interact with the UI through XML file. Now coming to the main activity, this onCreate method is called when the activity is created, and in this line this inflates the binding inflates the layout and assign it to the binding variable, helping to work with views defined in the XML layout. The set content view sets the inflated layout as the activity's content view. Now the set up recycler view function sets up the recycler view, and the codes view model dot fetch codes calls the view model to fetch code data, and the observe codes calls a function to observe codes data. Coming to the setup recycler view, here creates a new codes adapter instance with an empty mutable list, and binding on recycler view dot apply uses an apply block to configure that recycler view. Now the layout manager sets the linear layout manager as the layout for the recycler view, which arranges items in a vertical list, and the adapter assigns codes adapter as the adapter for the recycler view. Now the observe codes function. This line observes the code's live data. When the code changes, the block gets executed and updates the codes adapter in the new list of codes. Okay, now coming to codes adapter file. Codes adapter class, which is responsible for displaying a list of codes in a recycler view in Android application, And this is the name of the class. It extends recyclerView.adapter, which is a base class for creating adapters that bind data to recyclerView. Now the private var codes list, this is the mutable list of codes object that the adapter will display, and the private modifier restricts access to the variables from outside the class. In the inner class, the codes view model is in inner class extends the recyclerView.view holder and is responsible for holding the views for each item in the recyclerView. This This constructor takes the view object which represent the layout for a single code item. Now the text ID, text author, text code, these are text view instances that displays the ID, author and the text of the code respectively. They are initialized by finding the corresponding views in the layout using find view by ID. So now the onCreateViewHolder function. This method is called when recyclerView needs a new view holder to represent an item. The parent view that this new view will be attached to, and the view type of the new view not used in this implementation. This line inflates the course item layout XML file into a view object, and a new instance of code view holder is created with the inflated view and returned. Now coming to the onBind view holder method, that is called to display the data at a specified position, and the view holder that should be updated that represent the contents of item at the given position. The position of the item with the adapter's dataset, and the codes variable retrieves the codes object at the specified position. After that, this text that sets the ID, the author, and the code in the corresponding text views. After that, the getItemCount method that returns the total number of items in the dataset held by the adapter, and this returns the size of codes list, which indicates how many codes are available to display. Now the update codes method updates the list of codes in the adapter and a new list of codes to replace existing ones, and this clears the current list of the codes. Now coming to view model. Okay, so the what is I want to explain about view model. The code's view model is a life cycle ever, meaning it survives configuration changes such as screen rotation. This allows it to retain its data and not refetch it unnecessarily. The view model holds the live data reference to the codes. The activity can observe the live data to get updates when the data changes, and the view model separates the UI logic from the data logic. And the repository handles the data fetching, while the codes view model deals with preparing and managing the data for the UI. And when the fetch codes method is called, it fetches codes from the repository. The view model observes the data returned by the repository, and when new data is available, it updates its own live data, which in turn notify the observers. The uses of live data allows the UI to reactively update whenever the underlying data changes and ensuring that the user sees the latest information without needing to manually refresh the view. So at first I explain about the repository. The repository class is responsible for handling data operation, including fetching data from a remote API, and this line initializes the retrofit API service using the service object to create an instance of API interface. The getCodes method fetches codes from the API and returns a live data list code, and the data variable that creates a new mutable list data instance to hold the fetch codes. And the call variable initiates a network call to fetch codes from the API. Now the call.eq method. This method sends the request asynchronously. It takes a callback to handle the response. The onResponse method is called when the response is received. If the response is successful, if update the data live data with the list of codes, and onFailure method is called if the request fails and it sets a data live data to an empty list. Now coming to the service object. This object provides a retrofit instance that can be used to create service instance for the API endpoints. The service object class is a singleton object that provides a retrofit instance, and this retrofit.builder, this creates a new retrofit builder. And here that sets the base URL for the API, and here the adds the converter factory to JSON to convert JSON data to Kotlin object, and then build the retrofit instance. This function creates service method. Here creates a service instance for a given interface, and this returns a service instance created by retrofit instance. Now the coming is API interface. This interface defines the API endpoints that can be accessed using retrofit. These get codes, this annotation specifies that the get codes method should make a get request to the codes endpoint, and this get code function, this method returns a call object that represent the HTTP request to fetch codes. The call object is parameterized with codes, which means it will return a codes object when the request is successful. Now coming to the data class. The codes data class, this data class represent the list of codes, and the code data class, this data class represent a single code with an ID, codes text, and author. So what is the meaning of these things? When you use retrofit to make a request to the API, it will return a call object that represent the HTTP request. You can then use this call object to execute the request and get the response. In this case, the getCodes method in the API interface returns a call object that represents the HTTP request to fetch codes. When you execute this request, it will return a codes object that contains a list of codes. The service object class provides a retrofit instance that can be used to create a service instance for the API interface, and you can then use the service instance to make requests to the API endpoints. And the data class. The data class represent the data that is returned by the API endpoints, and they are used to deserialize the JSON data written by the API into Kotlin object. Now, now coming to the repository. In these get codes, we create a service instance for the API interface using service object. We then use service instance to make and request the get codes endpoint. When the response is received, we can access the codes data and do something with it. Now coming to codes view model. The codes view model class extends view model. This means it can survive configuration changes such as screen rotations, allowing it to retain data across activity recreations. This line creates an instance of the repository class which is responsible for fetching data from the API. And the code's a private mutable live data instance that holds a list of code objects. It can be modified within the view model. A public live data property that exposes these codes. Other classes can observe this property but cannot modify it directly. Now the fetch codes method that triggers a fetching of codes from the repository, and repository.getCodes calls the getCodes method from the repository which returns a live data list code. Observe forever. This method allows the view model to observe the live data returned by the repository, and when new data is available, it updates the codes property with the new list of codes. So what is the conclusion? It's all about the conclusion. So what is the conclusion? Main activity starts first and displays an empty recycler view. Codes view model fetches data from repository, and repository calls the API using retrofit. These service object and API interface, and after that data is sent back to main activity and displays using codes adapter. And the app, after the app running,